Hi dear students. So in the last class we were discussing mainly this one, Huckel's rule of aromaticity. So I will elaborate Huckel's rule of aromaticity today. This will take little time, but this will be very useful for entrance exam. Okay. So let me complete this aromaticity. Okay. So I have told in my last class that the first very important criteria to check whether a given compound is aromatic or not. What was that? You need to check the given compound is cyclic or not. For example, if you are given a compound like this, example I am taking, okay, something like this. What is this? Okay, this is the compound given. And you people know that this compound is benzene, correct? Now, how will you check whether it is cyclic or not? Now, check the carbon atoms, how it is connected. So, it is connected to this one, it is connected to this one, it is connected to this one, it is connected to this one. This is connected to this one and this is connected. So that means it is cyclic in nature. There is no openness in this compound. So I can say the first criteria is followed. Understood? Now the next criteria to check whether the given compound is aromatic or not is called what actually? Plenarity. What is that? Planar or plenarity. You can say anything. Planar. Now I told that to check the plenarity. Plenarity means what? The ring structure, this carbon, this carbon, this carbon, this carbon, this carbon and this carbon, all these should lie in one single plane. It can be horizontal plane, it can be vertical plane, whatever be it, but it should be in one single plane. Understood? How will you check that? For that we need to check the hybridization of all these carbon atoms. For example, if I am marking this as carbon number 1, this as number 2, this as number 3, this as number 4, this is number 5 and this is number 6. I need to check all the 6 carbon atoms are having the same hybridization. What is that hybridization which confirms the planarity? I can say we need to check whether the carbon atoms are sp2 hybridized. So if the carbon atoms are sp2 hybridized, then I can say all these. Because why I am telling that? Because in chemical bonding chapter you will learn that if you have sp2 hybridization, the shape is square planar. So planar means it is all lying in single plane. So we will check whether 1, 2, 3, 4, 5, 6 all these have sp2 hybridization. Now the next question is how to identify the hybridization of carbon atom. That is what I am going to explain. Okay, last class I could not explain all this because otherwise you will not able to understand this. Okay, listen, how to check the hybridization, that we are again going to deal this as a separate topic, but to identify that I will tell you a shortcut also. Listen. Now suppose you can think about the hybridization of carbon I am speaking about. Okay, I will mention here I am going to speak about hybridization. Okay, hybridization of carbon. Okay, so I am going to speak about hybridization of carbon. Now what is the atomic number of carbon? Carbon has the atomic number, carbon atomic number is 6. So what is the configuration? I can say 1s2, 2s2, 2p2. Correct? 1s2, 2s2, 2p2. Now I know that which is the valence orbital? 2 is the valence orbital. Correct? So in this 2 valence orbital, what are the orbitals which are taking part? We know that s and p are the orbitals taking part. So I can say with S and P, what are the possible hybridizations? There is no d orbital. So I can say with S and P, there are 3 possible hybridizations. With S and P, it can be sp3, or it can be sp2, or it can be sp hybridization. These are the 3 possible hybridization that is possible for carbon. So I need to ensure which one? All the carbon atoms are sp2 hybridized, because sp3 hybridization has the shape tetrahedral. Tetrahedral. Now sp2 has the hybridization planar. It can be square planar, usually square planar. Now sp, if it is sp hybridization, what will be the shape? Shape will be linear. Now to check the planarity, I need to ensure that the corresponding carbon which I am investigating should have what hybridization? sp2 hybridization. Now I will tell the shortcut. Now what is the valency of the carbon? You know that valence orbital is 2. Here also 2, here also 2. So total how many valence electrons are there? 4 valence electrons are there. So the valency of the carbon is 4. Valency of the carbon is 4. Now let's say how this 4 valence electron can get arranged in this s and p orbital. That give rise to something called hybridization. Okay, we will see that. So let me rub this. So I hope you got a little bit understanding. So hybridization is a detailed topic that will be handled in the chapter chemical bonding. Okay. Now I can say carbon now has the valency 4. So that is this. I know that one electron is with the carbon. Now whenever it forms bonding with the other one, it will get one more electron and the orbitals will get occupied completely. Now the question here is how these 4 valence electrons can get arranged in the s and p orbital. I told you that it can be arranged in the fashion sp3 or sp2 hybridization possible or sp hybridization possible. Now please listen, shortcut. Now whenever you have a carbon's valency arranged like this, okay, if it is, what are the possible format I am trying to write? It can be like this. This is one possibility, this is another possibility, then what is the third possibility? We learned this in our smaller classes. This is the third possibility. Everywhere its valency is 4. 1, 2, 3, 4. Here also 1, 2, 3, 4. Here also 1, 2, 3, 4. But they get arranged in different fashion. This is called a triple bond. This is called a double bond. This is called a single bond. One more possibility is there. That is this one. Correct? Is there any other possibility other than this 4? I am sure this is the 4 possibilities. Now we need to say the hybridization of the carbon in all the 4 possibilities. Then it is very easy for you to identify which is the hybridization. Okay. Now listen. If this is the possibility, I can say the easiest method is just to distribute here. Yes, and we know that what are the possible hybridizations possible? It can be sp3 or it can be sp2 or it can be sp. Now how many valencies are here? 1, 2, 3, 4. All are separate. In that case what I will do is, in this one I know that p is 3 and s is 1. So totally 4. So I can say this is s, p, p, p. You just distribute s and then p. Simply distribute it. Then you will get the answer. So some students will ask, sir, whether I need to write s here or can I write s here? You can write s anywhere because it is a shortcut. Okay, so I have given s, then I have continued with the p. Why I am writing only one s? Because in all these cases, all the 3 possibilities, there is only one s is there. Remaining is p. So here 3p is possible, 2p is possible, 1p is possible. So here since s I have written, 1p is written, 2 more are remaining, I put p here. So I can say the hybridization of this one is sp3. Always whenever you have this carbon is coming like this, it is satisfied by 4 different valencies, means it is sp3. Understood? Now coming to the next one, this one, whenever double bond comes or whenever 2 valencies are coming together, we should take that as together. Okay, now again do the same thing, give here, starting from here s here, then p here, and for the 2 we should give only 1. We should take it together. So now tell me what is the hybridization of this one? The hybridization of this one is sp2. Understood? So we need to check in our compounds whether this hybridization is present or not. Clear? Now coming to here, can you tell me now 3 are coming together, so we should take that together. Now put s here, then together we put p. So what is the hybridization for this one? sp. Now coming to the next one, here double bond, so I will take it together. Here also double bond, I will take it together. So this is s and this is p. So here also the hybridization is sp. Understood? So this is the possible way we will find the hybridization. Now let's switch to the planarity and see in the given compounds how to identify whether it is sp2 hybridization or not. I hope this is clear for you. If you have not understood, please rewind the video and see it, and still the doubt exists, you can ask in the doubt clearance session. Okay, so let me rub this. So this is just a method to identify the hybridization of carbon. So as I told, carbon has its valence electrons will enter only in s and p orbitals. So the hybridization is possible only with s and p orbitals. So hybridization means mixing of the orbitals to form orbitals of same energy. So we can say the possible hybridization are for carbon are sp3, sp2 and sp. Suppose d orbitals are also there, then it will comes like sp3d2, like that it will come. For carbon it will not come. Why? Because the valence electrons are entering only in s and p orbitals. Clear? Okay, now we will take some examples and identify the hybridization. Okay, examples. Now let's start with benzene itself so that it becomes easy for you. We have given benzene initially. Now tell me, for each carbon atom, what is the hybridization? How will you check that? Now going for the first carbon atom, let me say this is my carbon atom, first carbon atom. Okay? Now how will you check the hybridization of that carbon atom? And I know that here the valency of the carbon should be 4. But one valency is coming in this direction and 2 are coming in together, and one more valency is there. Where that valency went? Because the carbon can form stable bond always with the 4 valencies, correct? So the other one is actually hydrogen, but they will not show that. So everywhere hydrogen is present. Now if you have doubt, you can write down the formula of benzene and confirm this. Okay? The formula of benzene is C6H6. So 6 carbons are here, 1, 2, 3, 4, 5, 6, correct? Now hydrogen 6 should be present, right? But if I draw just this as the structure, where is the hydrogen? It is not there. Actually hydrogen is present like this, hydrogen, 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 hydrogen. This is how the actual structure of benzene looks. Now we will see the hybridization of carbon one by one. Now here, tell me what is the hybridization. So let me start with here S, this is P, and together I am taking this as P. Now what is the hybridization of this carbon? sp2. So I can say this is sp2. Now I can rub this and I will go to the next carbon atom. Okay, when I go to this carbon atom, again double bond is there. I will take it together. Then I will give here S, then this is P and this is P. So I can say again this is what? sp2. Understood? Now I will go to the third one. Here also I am coming. So I will give here S, this is P, and this I am taking together. Then this is P. So what is the hybridization of this one? sp2. Okay. Now I will rub this. Now I will go to the next one here. Now near to that there is one. So here also I am taking this together. I am giving it S. This is P. This is P. So what is this hybridization? Again this is sp2. So some students still ask a doubt. Sir, here when you are considering this carbon, you take this as P and now you are taking it as S. That is not a problem because this is a shortcut to determine the hybridization. Okay, it's not an actual rule. Okay, so I have told you that. Now let me go to the next one. So when I go to the next one here also, let me see. So double bond is there. So I will take that together. Now this is S, this is P and this is P. So what is the hybridization of this one? sp2. Understood? So let me go to the next carbon atom. So coming to this one, this is S, this is P, this I am taking together. So this is P. So this is what is hybridization? sp2. Understood? So I identified that for all the 6 carbon atom, the hybridization is sp2. That means the given compound is planar. Understood? So this is very important, identifying the hybridization of the carbon atom in the ring structure. Not the carbon atom, the structures that is connected together. There we need to ensure that all are sp2. Then all will lie in one plane. That will ensure that it is a compound is a planar compound. Okay. So I hope that is clear for you. Next we will try to see a few more examples. Okay. Then you will get familiar with this. Okay, so let me draw some structures, then you need to tell me whether it is planar or not. Okay, so you have a structure like this. Suppose a structure is given like this. Can you tell me the compound is planar or not? So what should be our method? So we should identify first the carbon atoms or connected ring structure. So this is one point, this is one point, this is one point. We need to see all these 3 points, or all these 3 carbon atoms are having sp2 hybridization. For carbon only, usually we will check this. Okay. Now coming to this one, you can see here one valency is satisfied here, one valency is satisfied here. Only 2 valency is satisfied for the carbon. So what will be the next 2 valency? I can surely say that is hydrogen atom. That will be not shown usually. So there is one hydrogen atom here, there is one hydrogen atom here. Correct? Now coming to next here, carbon atom, one valency is going in this direction, 2 valencies are going in this direction. Where is the 4th valency? That is a hydrogen atom. So I will show it like this. Okay. And coming to the last one, here also one valency going like this, one valency going like this, one valency. So where is the last one? So always ensure that carbon has 4 valencies. That is very important. Okay. Now I drawn the actual structure. Now I need to determine whether the compound is cyclic. We will do from the starting condition. Cyclic means, yeah, it is connected to this one, it is connected to this one, it is connected to this one. So first condition is correct. Now what about the next condition? That is the planarity. So let me say this is my first carbon atom. Okay. So tell me whether this is planar or not. Let me say how I will do that. I will put for one valency yes, for the next valency p. So for the third valency again p, there is another valency p. So what is the hybridization here? sp3. That means that carbon atom is tetrahedral. I don't want to check further, because if any of the carbon atom is not sp2, surely that carbon atom will be in a different plane or shape. Then that compound is not planar. Actually I can stop from here, but I can check here also. So if I check here, this is yes, correct, this is p, this is double bond, I am taking it together, so this is p. So this is hybridization is sp2. Understood? Now coming to here, this is yes, this is p, and this is double bond, I am taking it together. So P. So this is also sp2. So I can say that 2 carbon atoms are sp2 hybridized, but the third carbon atom is sp3 hybridized. So the compound is not planar. It is not planar. Clear? I hope it is clear for you. Okay. Now I have a third possibility. That is what I am going to tell. Okay. Listen. Now let me say, okay, listen. Now you know that whenever a bond is broken, let it be single bond. Okay, let this be carbon-carbon bond. Okay, now tell me what happens when a bond is broken. Now I know that there are 2 electrons are in this bond. Now this bond breaking can be of different types, or the bond cleavage can be of different types. I will come to that. But for explaining my concept, I need this. Okay. So I can say that you can think actually when bond is broken, you can think like, sir, when bond is, it is the electron of this carbon, it is the electron of this carbon. So when the bond is broken, they will get back the electron. This is our normal thought process which favors equality. Correct? Okay. I can say when this bond is broken, carbon will have 1 electron, this carbon will have 1 electron. What is the reason for that? You can think like both are carbon atoms. So both are pulling in this direction in an equal strength. So when the bond is broken, each will get its own 1 electron. This type of species are called free electron species or radicals, you can say. Now suppose I am going to give you another case. For example, something like this. Carbon is there, okay, the other species is a chlorine. Okay, now we know that chlorine, what is the valency? 7. So surely there will be 2 electrons here, 2 electrons here, 2 electrons here, and 1 valence electron is coming here. Correct? Now for carbon we know the valency is 4. So that means 1 electron is here, 1 electron is here, 1 electron is here, and 1 electron. So with these 2 electrons it has formed the bond. Now comes the problem. Now think like this bond is being broken. So what will happen here is there is a difference. Because when I am comparing, these two are different atoms, different atoms, carbon and chlorine. And if you see, there is a parameter in chemistry that is called electronegativity. So what do you mean by electronegativity? Electronegativity means it is the power or the ability of an atom to attract the electrons. It is also called electron affinity. You can take electron affinity or electronegativity. So if somebody is electronegative, that means what actually? It has a tendency to attract electrons. And you can say that, sir, I understood the term electronegativity. In carbon and chlorine, who is more electronegative? How we can identify that? Very simple. Just to check out the configuration of chlorine. Chlorine has the electronic configuration 2, 8, 7. Now tell me, for chlorine to attain the octet, whether it needs to attract the electron or it will lose the 7 electron. You know that to attain stability, what it should do? It should attract one electron. This tendency of the chlorine to attract the electron to attain stability is called electronegativity. Now take carbon. What is the configuration? 2, 4. Now tell me, for carbon, what is the tendency? To lose 4 electrons or gain 4 electrons? You know that carbon, it has a tendency to share the electrons. Correct? So I can say that who is more electronegative here, chlorine or carbon? I can clearly say chlorine is more electronegative than carbon. So here tell me, with whom the carbon has formed bond? It has formed bond with chlorine, and I know that chlorine is more electronegative. If chlorine is more electronegative, what this will do? What chlorine will do is, chlorine will attract this electron towards its side because it is trying to become stable. In this case, when the bond is broken, what will happen? I know that carbon will lose 1 electron. So what will happen to the carbon? It will acquire a positive charge. Why it is acquiring a positive charge? Because it has lost 1 electron. So losing 1 electron means the number of protons will be greater than the number of electrons. So that is why positive charge is coming here. Now similarly, when chlorine gains 1 electron, what will happen to the chlorine? It will gain a partial negative charge, Cl minus. Why? Because it has an excess electron compared to the proton. That's why minus charge is coming. Understood? So depending upon the type of bonding between the atoms, when a bond is broken, so you could see here a cation and an anion is formed. These are the two types of bond breaking. So in the initial bond breaking, where carbon and carbon was present, so when bond was broken, carbon was with 1 free electron, another carbon was with 1 free electron. So this type of cleavage is called heterolytic cleavage. What is that? Heterolytic cleavage. So heterolytic cleavage will give rise to what? This is L, okay. So heterolytic cleavage will give rise to cations and anions. Now this is called homolytic. Homolytic means both are same. So homolytic cleavage will give rise to what? I can say free radicals. Free radicals. Free radicals are species with the free electrons. Okay. So I hope you understood the bond cleavage concept. Now let me tell how this concept is used here in questions. Okay. So if you have any doubt, please come back to us in doubt clearance session. Don't feel any bad. Okay. So let me say how this concept is coming in here. So let us take an example to understand how that is coming. Okay. So consider this species. Consider this species and tell me whether the compound is cyclic and planar or not. Okay. So you know that first criteria is to check the cyclicity. So I know that this carbon atom is connected to this carbon atom and this is connected to this carbon atom and that is connected. So cyclic, the compound is cyclic only. I understood the compound is cyclic. Correct? So the next condition is I need to check whether it is planar or not. Correct? So for that, let me say here I know that one valency is going here, one valency going here, one valency. So third valence, the last valency is a hydrogen. Here also one valency coming here, one valency going here. So 3 valencies are satisfied. The other is a hydrogen. Now comes the third carbon atom with a positive charge. So with a positive charge, just now we have seen that when a positive charge will come, you know that when it loses some electron. So I can say that there is one valency here, one valency here. And positive charge indicates one valency is gone. How? Because when carbon has 4 valency and the one electron is this valency, during bond breaking, it goes to this electron goes to someone else. Then only what will come here? The positive charge will come here. Understood? So positive charge, one positive charge indicates it has only how many valency? 3 valencies are only there. So I understood that one valency went here, one valency went here. So the third valency is hydrogen. But one hydrogen has went to someone else. It can be due to chlorine or it can be anything. We don't know. Anyway, what they have given here is a cationic species. Understood? Now tell me what is a hybridization then in this case. Now let me say again. So here if you say this is S, this is P, this I am taking together, this is P. So this hybridization is sp2. Correct? Now coming to here again, this is S, this I am taking together. So this is P and this is P. So the hybridization is sp2. Now coming to this one. Now tell me here also S. Correct? This is P and this is P. Anything else is present? No. So I can say what is the hybridization of this one? sp2. Understood? Earlier when this positive charge was not present, what was the hybridization of this carbon? It was sp3. Now due to bond breaking, one species hydrogen has went out. Now the hybridization changed to what? sp2. So I can say that all the 3 carbon atoms are sp2 hybridized. That means the compound is planar. Understood? So this is the reason, or this is the why I am telling you need to be very cautious while you are attending the question. They can, one year they can give this compound with a positive charge, next year they can give with a negative charge also. Let me say what negative charge comes, how is the hybridization changes. Okay. So don't feel any doubt, very simple. To understand this positive charge, I have explained all the bond breaking and those concepts. Otherwise you will not understand if I simply keep a positive charge. Okay. I hope the explanation is clear for you. We will see one more example to get another understanding of planarity. I can say after all my explanation, you cannot expect any question outside from this, I am sure. Okay, because I will be referring that many books as well as everything as much as possible to give you the lecture. So please listen to the lectures and take down the notes and learn that first. Then only go to any other extra books if you want to learn. Okay, so that is why, that is very important. You can also talk to our toppers last year, or you can see their video in YouTube. They are explaining it very clearly. So please follow the instructions strictly and continue until the last minute. I am sure you will get more than 650 or 600 plus. I am sure. So please do that. Okay. So let me say, we will see the next example. Okay. So let me start with the next example, so then you will get a fair idea of this one. Okay. Okay, so the next example I would like to show is this one. Again, the same thing, but only one difference is there. Okay, go through this. Now you understood that the only difference I made here is instead of positive charge I made it as negative charge. Will it impact or not? So when a negative charge comes, you know that when electrons comes there, correct? So what will happen here is, again you can see here one valency is going here, one valency is going here. The third valency is a hydrogen. What happened to the fourth valency? That fourth valency, now you know that there is no chemical bond is here. So this was, now this is the species. You know that hybrid orbitals are formed when chemical bond is formed. So here only 3 chemical bonds are there and the other is a negative charge. That is yet to form a hybrid orbital. So can you say whether this has a hybrid orbital then? No. Then what should be the way? Again it is the same. This is S, this is the P, this is P. So what is the hybridization here? sp2. Understood? So please understand, so whether it is positive or negative charge, it does not have any impact. Why? Please understand the reason, because now you have a negative charge with the 2 electrons. These have not entered into hybridization. How electrons enter into hybridization? Whenever it enter into a chemical bond formation, that is called, that chemical bond can be the hybridized orbital. That is not happened for this species. Then I can say here only hybrid orbitals are spp, then sp2. All these are sp2 hybridized orbitals. This is yet to form the hybridization. Understood? So very simple. So you might have understood. So this is sp2 hybridization. Or you don't want to think too much to understand the physical sense, you can put here spp, only 2 valencies. So 4 valencies should be there. So third valency I have kept. Since minus charge is there, I understood that one bond has underwent breakage. If there is 2 minus charges there, understand what does that mean? 2 bonds have undergone breakage. Okay. So then since there is only one negative charge, it means that one bond has underwent breakage. One bond has broken, so that means that bond is no more a hybrid orbital. Okay, so coming to here, one valency going here, one valency going, so the fourth one should be hydrogen. So I know that this is sp. So this is sp2. So similar case, so here also hydrogen is present, so this is sp2. Now tell me, cyclic is there and the compound is also planar. Clear? So I have tried to explain all possibilities with the planarity. Now comes the third condition, the most important condition, that is called cyclic resonance. So to understand the cyclic resonance, I should first explain what is resonance. We have a big topic resonance here, but here I will explain what is resonance, okay, to make you more familiarized, because without understanding the physical concept, it will be very difficult. Then I will explain what is cyclic resonance. Then we will check. I will give you a shortcut to identify. Here the condition is, what is the third condition? Let me write. The third condition is to check cyclic resonance is present. To check cyclic resonance is present. Okay. Or you can just write a shortcut, cyclic resonance. To ensure that cyclic resonance is present, that is the third condition. To explain that, I will first go with what is resonance. Okay, listen. Okay, so next let me start explaining what is cyclic resonance. So before that, as I have told, I will explain what is resonance. Okay, this is a small detailed understanding. I will go into detail in the upcoming sections, because there we need to learn what is. So what is resonance? So I am just telling, resonance means delocalization of pi electrons present in a pi bond. So the next important doubt that is coming to you is, sir, what are the different types of bonds that is possible between different atoms? I can say there can be ionic bond. Oh, sorry, there are different types of bonds. Let me say sigma bond, then pi bond, then I can say coordinate bond is present. So here we are speaking about pi bond. Now I have told in my last class also how a sigma bond is formed. Sigma bond is formed whenever you have the hybrid orbitals, when they overlap in an axial manner. Okay, this is called axial overlapping. Okay, so this will give rise to what is called a sigma bond. Understood? I told you that all these orbitals, it will undergo hybridization. That's what hybridization you will learn. So understand, this is a hybrid orbital and this is a hybrid orbital. And if they are overlapping axially like this, the type of bond formed there is called a sigma bond. All single bonds are sigma bond. Okay. Now let us say the other possibility. Sometimes you can see these bonds are overlapping in another way. That is called okay, 1 minute, let me draw that. Like this. So here you can see that they are not overlapping like this, they are overlapping like this. So this is one overlap coming here, this is another overlap coming here. So this gives rise to something called double bond. Okay, so I can say this is called a pi bond. So usually whenever a pi bond is formed, so even though there are two overlapping is there, this is a very weak bond, because if this is extending and forming the bonding, so if you give some amount of energy here, this will break very fast. So that's why you have, whenever a pi bond is formed, for example in the case of a double bond, one bond will be a sigma bond, okay, and this bond will be a pi bond, and this pi bond is a weak bond. Why? Because it is formed by lateral overlapping. So this is called lateral overlapping. Okay, so lateral overlapping will give rise to a pi bond, and that pi bond is a weak bond. So if it is a weak bond, what will happen? This bond also, if it is breaking, so if you give small amount of energy, this will break. So what will happen? This will form two electrons, correct? Bond is broken and you have the two electrons, and this bond can easily be broken. I mean this pi bond alone. Don't think like both can be broken easily. That is different. I am talking about pi bond alone. It can be very easily broken compared to sigma bond. So since it is very weak bond, it keeps on moving from one location to the another. This movement of the pi bond or pi electrons from one location to the another is referred to as what actually? Resonance. Now students will ask one doubt usually at this point of time. They will ask, sir, if these pi electrons are shifting from one carbon to the other carbon, what will happen to the valency and stability, sir? How it can happen? If it is shifting, means immediately what will happen? Electrons move from one place to the other. There is a deficiency there. Then positive charge will come there. Where the electrons is moving, there what will happen? A negative charge will come. So if positive and negative charge is coming into a species, means they are becoming unstable, because they will keep on attracting, or they will attract other species. Sir, then how this is possible? Very, very good question. Okay, that is what I am going to explain next, that is conditions for resonance. When a resonance will happen, it does not mean that if you have a pi bond it will start moving. It is not like that. There are certain conditions. If that conditions is followed, I can say in that particular compound resonance is present. That is what next I am going to explain. Listen. Okay, so conditions for resonance. Then we will learn what is cyclic resonance. We can go step by step only, otherwise you will not understand. That is, I am sure about it. Okay, now next we will try to understand what are the conditions for resonance. So here I will tell you one shortcut, you can just follow that. But let me tell first conditions of resonance. Okay. So I will give you an example first, and with that I will try to explain, then I will give you my shortcut, then it will be easy for you to relate. So let me take my famous example, that is nothing else, my benzene. Okay, so this is my benzene. Now the most important question here is, sir, benzene have a resonance or not? Very good question. Listen. The condition for resonance, I told like this is my pi bond, this is one pi bond, this is another pi bond, this is another pi bond. So totally how many pi bonds are present in benzene? I can say 3 pi bonds are present in benzene, 3 pi bonds. So 3 pi bonds means one pi bond is made up of how many electrons? 2 electrons, correct? Let me mark that, 2 electrons. So totally how many pi electrons are there? 6 pi electrons are present. Okay. Now I told you the shifting of the pi bond from one position to the another is referred to as what? Resonance. Correct? Now I told you that every pi bond will not shift. There are certain conditions for that. I can say the first important condition is called conjugation. Please understand. First, the most important condition is called conjugation. So I can say if conjugation is present in a compound, then there is a possibility of resonance. So many students will ask me, sir, what is conjugation means? Let me explain. Conjugation means, now if you see here, here is a pi bond, then a single bond, then a pi bond, then a single bond, then a pi bond, then a single bond. So this alternating nature of pi bond, then single bond, then pi bond, then single bond, then pi bond, then single bond is called conjugation. Now, if conjugation is present, how it will give rise to resonance? Listen. Now, as per our understanding, we know that one pi bond is present. So, pi bond will shift towards another pi bond. That or delocalization of pi bond will happen. Now, when this pi bond is shifting in this direction, it has moved to this one. What will happen? This pi electrons will repel this pi electron. So, this will now shift. It will shift in this direction. Correct? Now, when this pi electron comes here, it will repel this one and this will form here. Now, you look at the structure, any difference? Only pi bond has shifted. No positive charge or negative charge has come. So, that is the reason why we say there should be conjugation should be present. Suppose if conjugation is not present, what will happen? I can give you an example for that. If conjugation is not present, I will give you another example. Listen. This is another compound I am trying to draw. So, here pi bond, here pi bond, here pi bond. Only this many pi bonds are there. Now, can you tell me resonance is present? I can tell resonance is present because shifting is happening. Correct? Now, how will you check whether resonance is present? Check for conjugation. Double bond, single bond, double bond, single bond, double bond. So, little bit alternation altering is there. But here after this double bond, there is single bond, then again single bond, then again single bond. That means in this part there is no resonance is present. Understood? So, I can say in this compound resonance is present, but cyclic resonance is not present. Cyclic resonance means in throughout the cycle there should be conjugation. Okay, so here when shifting happens, what will happen? This will shift in this direction, correct? So, this will repel this pi bond, so it will shift towards this direction. So, this will repel this one, so this will shift towards this direction. Now, is there any other possibility? Nothing. Again, this will shift in this direction, then this will shift in this direction, then this will shift in. So, this keep on changing like this. This is called resonance. But cyclic resonance, can I guarantee? No, because after this, you can see here single bond, here also single bond. There is no conjugation or alternation is not present. So, I can say in this compound resonance is present, but cyclic resonance is absent. For aromaticity, the condition is the compound should have cyclic resonance. And next important question that comes here is, sir, whether this only the pi bond will take part in conjugation or whether any others also will take part in conjugation. Very important. Other than pi bond, the positive charge, negative charge, the lone pair of electrons, even single electron can also take part in conjugation. Listen here. For that, I will give you an example. Everything here we can learn with an example only. Please understand. Then only you will understand. Otherwise, the single statement will make you confused. We will try to see the example. So, let me draw this example for you. Okay, I hope you have seen this example earlier. Now, tell me here whether cyclic resonance is present or not. So, listen here. As I told, double bond is present here, single bond, then comes positive charge. Then single bond, then double bond. Understood? So, my condition is very simple. Always, I can say this can be positive charge, this can be negative charge, or it can be lone pair of electrons, or it can be single electron, or it can be another pi bond. Okay? So, this also can be anything. Positive, negative, lone pair, single electron or pi bond. So, basically speaking, this is my shortcut for you. If you remember this, with this you can easily check whether cyclic resonance is present in the compound or not. What is this shortcut? Listen, always the single bond. Okay, you can see first time anything can come. Either a positive charge can come or a negative charge can come, lone pair can come or a free electron can come or a double bond can come. Always that should be followed by what? A single bond. Then again anybody of this can come. Again what should happen? A single bond. Again what? Anybody of this. Again a single bond. That alternation is called conjugation, or to check the presence of resonance. And if this alternation is present throughout your cyclic ring, then we call that as cyclic resonance. Okay. Now you tell me, apply this rule. I can start with here. Anywhere you can start with. First positive charge. Correct. Positive charge can come. Correct. Then what should come? Single bond. Yes, single bond is present. Then I know that anybody of this can come. Who has come here? Double bond has come here. Correct. Then what should come? Single bond. Correct. Then what can come? Any positive charge. So it keep on coming throughout the cycle or throughout the cyclic structure. So I can say this is following cyclic resonance. Understood? Now I will give you another example. You should tell me whether cyclic resonance is present or not. Okay, now students also want to see, sir, how in that compound cyclic resonance is happening. That I will explain here. For example, I will draw the structures. Drawing the structures and how to draw that, all these things we will learn in the next section. Now it is not required for aromaticity. That's why I am not explaining in detail. I will explain this section one more time. Please be patient. So here, positive charge is there. Now, many students will ask, sir, how will you draw cyclic structure? So for that some definite rules are there. I told it is a shifting of what? Pi bond. So this pi bond will shift towards which direction? Any direction, towards here or here. Anything is possible. Suppose it is shifting in this direction, it will give you the next structure. What is that? You can see when it is moving in this direction, double bond will come here. So when double bond is coming here, the deficiency of this carbon atom will be lost. But when double bond is moving in this direction, this carbon atom is losing the electron. So this will become what? Positive charge. Actually, some students will learn like, sir, when double bond come here, the positive charge moved from here to here. That is also correct, but logically speaking, what is the reason? Here there is a deficiency. So when double bond is shifting in this direction, what will happen? The bond that is present in this carbon atom is lost. But here there is no change because here the double bond is also present with this carbon atom. So when that is lost, here positive charge will come. But if you see the structure is the same. It's called a resonance. So how, when a pi electron and a double bond comes, how the bond will shift, in which direction it will shift, though there are a set of rules are there. When two pi bonds come, one pi bond should move towards the another, and if positive charge and a pi bond comes, then pi bond will shift towards the positive charge. There are certain rules are there that I will teach you in detailed class of resonance. Okay, now let us, you can understand this is how resonance is happening. So in next time what will happen? Again here there is a deficiency, so this will try to move in this direction. So what will happen? You will get the next structure, like this will move to here, then it is moving here, means the deficiency of this will be, this carbon will remain the same, the bond is moving to this direction. So this carbon will become deficient. So this will become positive charge. So this keeps on changing. So many students will ask, sir, what is the actual structure of this compound? I can say there is a hybrid structure. I will come to that in resonance. So these are all different possible structures for this compound. Okay. So now let us learn here how to check whether a given compound have what? Cyclic resonance or not. So if that cyclic resonance is just present means, then I have one of my criteria followed. That is what I need to focus now. Okay. So let me draw some other examples and you need to tell me whether cyclic resonance is present or not. Okay. Okay. So let me draw one more structure. Okay. Okay, we will check all the three conditions, then it will be easy for you. Okay. Now first condition, tell me whether the compound is cyclic or not. Yes, we can say, look, so this is connected to this one, this is connected to this one, this is connected to this one, this is connected to this, and it is connected back here. So I can say this compound is cyclic. First condition is followed. Correct? Now what is the next condition? Planarity. For planarity, what should I check? I check the hybridization of all the carbon atoms. So let me start from here. So I know that one valency going here, one valency going here, one valency going here. So where is the last valency? That should be a hydrogen atom. So if I check S, this is P, this I am taking together. So this is P. So the hybridization here is sp2. Correct? Now the next condition coming to here. So here also one valency coming here, one valency going here, one valency going here. So where is the last valency? That should be hydrogen atom. So S, P, this I am taking together, P. So this will become sp2. So two carbon atoms are sp2 hybridized, that I understood. Now coming to this one. So here one carbon atom going, one carbon atom going. So you understood there is a positive charge. That means one bond is broken. So there is a third valency is a hydrogen atom. So that is spp. So that means this is also sp2. So I understood this is planar also. The compound is planar. Correct? Good. Now let me check for the last condition, that is cyclic resonance. Let me rub this, otherwise it is difficult for you to understand. Okay. It's better that I will draw the structure one more time so that it is time saving can be done. Correct? Okay. So I hope all the students are understanding, and if there is any misunderstanding or if you are not understanding, please let me know. Okay, this was the structure. Now how to check whether cyclic resonance is present or not? I can start from anywhere. Plus charge. Then what should come? A single bond, correct? Then what can come? Anything can come. So here double bond, then single bond, then double bond, then single bond, then plus charge, single bond, double bond, single bond, double bond, single bond, positive charge, single bond, double bond, single bond, double bond, single bond, positive charge. You can see here cyclically this resonance is present. So I can say here cyclic resonance is present. Cyclic resonance. Understood? I hope you got a fair idea. Now I can give you another structure, and you can check whether cyclic resonance is present or not. This is very interesting. Once you understood this, this is like a cakewalk. Okay. So let me say one more structure I will draw. There are a lot of examples. We will try to discuss all this in a video so that you should be very much confident actually. Okay. Let me say I will draw this compound. Now can you tell me in this compound whether cyclic resonance is present or not? How will you check? I can start from anywhere. Double bond, single bond, super. Double bond, single bond, but again here single bond, again here single bond. I can say there is no cyclic resonance. But if somebody asks whether resonance is present, yes, double bond, single bond, double bond. So it keeps on moving like only from here to here. It will cannot move in this direction. So as I told, cyclic resonance means it should be present throughout the cycle, but here it is not present throughout the cycle. So I can say cyclic resonance is absent. Cyclic resonance is absent. Understood? But if resonance is present means yes, resonance is present. So a little bit conjugation is present. Double bond, single bond, double bond. Clear? So I hope the cyclic resonance concept is somehow clear for you. The shortcut is very simple. Check for double bond, positive charge, negative charge, lone pair, free electron. It should be in alternation with single bond. Again it can be double bond, positive charge, negative charge, lone pair, free electron, again single bond. It keep on going like this. If this is present alternatively, that is conjugatingly. The conjugation term is a mathematical term. You might have learned conjugation. A plus IB, the conjugate of that is A minus IB. From there the term has came here. Actually we should say alternation. That is very simple. So alternatively this happening means, that means cyclic resonance is present. Very simple. Clear? Okay, now comes the last condition. What is the last condition? Tell me. 4n plus 2 pi electron. Very, very important. If all these four criteria are followed, then only I can say what actually the compound is aromatic. If any of these criteria is not followed, then the compound is not aromatic. So the fourth condition here is, tell me what is the fourth condition? 4n plus 2 pi electron. We need to ensure whether in the given compound whether it has 4n plus 2 pi electron. What is this 4n plus 2 pi electron? Listen here. Very simple. So 4n plus 2 pi electron means put here different values for n. N is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. So tell me, you can still keeping it, no issues. Okay, when you keep 0, 4 into 0, 0 plus 2. So how many pi electron will come? 2 pi electron. Now put 1, 4 into 1, 1, 4 plus 2, 6. So I can say 6 pi electron. When you keep n is equal to 2, 4 into 2, 8, 8 plus 2, 10. So 10 pi electron. And last one, when 3, 4 into 3, 12, 12 plus 2, 14. Actually speaking, you don't want to substitute like this. This is an arithmetic progression. This is 2. If you add a common difference 4, this will become 6. When you add a common difference 4, this will become 10. If you add a common difference 4, this will become 14. So when n is equal to 4, what will be the value? Can you tell me without substituting? I can say it is 18 pi electron. Now what is the significance of this number? That is what I am going to tell. What you need to do is, suppose you are given a compound like this, benzene. Again I am taking the benzene. What you need to do, just count the number of pi electrons. So here, or you can say just count the number of electrons that is entering into cyclic resonance. Very, very important. You can learn like this. You can learn like that. Count the number of pi electrons that are entering into cyclic resonance. So here I know that this will enter into resonance, this will enter into, this will enter into. So here 2 electrons, here 2, here 2. So totally how many pi electrons are there? 6 pi electrons are there. Just take that number 6 and check it is coming in any of these. I know that 6 is coming here. Super. So that means this is following what? Huckel's 4n plus 2 pi electron rule. Suppose the structure is like this. Now tell me how many pi electrons are there? Here 2 pi electrons are there, here 2 are there. So 2 plus 2, how many are there? 4 is there. Now I am looking here. Anywhere 4 is present. After 2, 6 is only there. After 6, 10 is only there. 10, then 14, then 18. There is no 4. That means it is not following Huckel's 4n plus 2 pi electron rule. Understood? So very simple. Suppose there is only, okay, 1 it is not possible. So very simple. I can give you one more example to understand this. Okay, check about this condition. So here I want to check 4n plus 2 pi electron rule. Tell me how many pi electrons are there. 1 pi bond is there means that 2 electrons. Anywhere any other electrons are entering into resonance? No. So only 2 electrons. I will check the number 2 here. Yes, 2 is present here. That means it is following 4n plus 2 pi electron rule. This is how it is very simple to check whether 4n plus 2 pi electron rule is followed or not. So basically speaking, if all these 4 rules are followed or criteria are followed, then I can say the compound is what actually aromatic in nature. So we will see more examples in the next class. I hope you understood. If you have any doubt, please you mention the same thing in your doubt clearance group, or you can, we have a live session coming on Saturday. At that point of time we will discuss. Okay. Thank you.